express f of x in the form a times all of x plus h all squared plus k. And as we should know that whenever we see this form or a related form, that what we are required to do with the expression is to complete the square. We therefore need to complete the square on this expression f of x is equal to 4x squared minus 8x minus 2. That form requires that we complete the square as we mentioned before. In completing the square, we need to convert a part of the expression into a perfect square as indicated in the form. The form contains a perfect square right here. Therefore, we need to arrive at a perfect square from this expression. While completing the square, we need to focus on the first two terms, or the variable terms of the expression. Those two terms will be our focus when completing the square. That is where the perfect square will be derived from. The perfect square will be derived from the first two terms, which are the variable terms of the expression. We will therefore get a hold of those two terms right at the beginning. But if we take a look at what we have right here, is that we have a constant multiplying all of this. Not only that, we have a 4x squared here. We do not have a number except for 1. We do not have a given coefficient right here, which is a strong indication that we need to remove this 4 from the x squared term. For the requirement of the form, 4 needs to be factored out. We need to take out that factor of 4 in order that we may have the x all by itself. So take the first two terms. Take the common factor of 4. When we take the common factor of 4, each of the terms will be divided by that common factor of 4. Those are eliminated to give x squared, and of course 4 into 8 will be 2 times. After taking the common factor of 4, the factor inside of the bracket will be x squared, which is right there, and of course the 2, negative 2x. Negative 2x will be the other one. Do not forget, this term will also be included. When we are completing this square, we need to maintain the integrity of the expression, ensuring that what we start with is what we end with in terms of the value. For the contents of the brackets to be a perfect square, there must be a third term. There we are, making provisions for the third term that should be included in the brackets that will make the expression inside of the brackets a perfect square, which means that we will be completing the square. The third term is the square of half of the middle coefficient. Take the middle coefficient, take half of it, and square the result, and we will get the third term. The third term is the square of half of the middle coefficient. The middle coefficient is negative 2, a half of that is negative 1. We square negative 1, we get a positive 1, and that will be the term that completes the square, which makes inside of the brackets all of those together constitute a perfect square. notice that we are carrying along with us the negative 2 that we started off with in order to maintain the integrity of the expression. Do not forget that this was just included and we need to make an adjustment for it. So everything can be accounted for from the above expressions, with the exception of that one that was introduced in the brackets in order to complete the square. We need to neutralize that positive 1 that we have right there. So this positive 1 just included, and we need to neutralize it, meaning that as if it's not there. What do we do to neutralize it? We will therefore subtract 1. We need to subtract 1. But it is multiplied by 4. Everything inside of the brackets multiplied by 4. Therefore, the 1 is also multiplied by 4. Instead of subtracting 1, we therefore need to subtract 4 times 1, which is 4. So we will subtract 4. We will subtract 4. And we have our square completed and the adjustment made. I think that we'll go over to the next slide to complete the entire thing. Let's use the next slide. Let us finish up on the next slide. We begin where we left off. And what do we know? How do we complete the square? The 4 will go to the next step just as it is. Here, we'll just include it there. But x squared is there. What do we square to give x squared? The square root of x squared is x. X will go there. Also, we have the middle term. Although that is not included, it is accounted for in the perfect square. The sign of the middle coefficient is next, which is negative. And of course, the square root of 1, which is 1, will also be included. There is our perfect square, and all that is left is negative 2 minus 4, which turned out to be negative 6. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.